The function board, display board, and the instrument board are the key players of the control system. The function board, which I often refer to as the main controller, operates both the cleaning systems and the wheel drive motor. The instrument board provides hardwired switch inputs to the display board and feedback to the operator in the form of LEDs. The display board operates the multifunction display based on what it is told to do by the function board. The display and the function board communicate with one another via serial communication lines.
One controller does it all on the SC500. The function electronic board, or main board, operates both the cleaning systems and the drive wheel system. The battery charger communicates with the function electronic board, and so does the display.
When the operator turns the machine on and presses the scrub switch, the switch input request is hardwired to the display board. The display board calls up the main controller and says, "Hey, the operator just pressed the scrub button." The main controller replies and says, "Okay, I'll get ready to turn on the scrub system. Meanwhile, please let the operator know."
The function board is essentially a box of switches with a microprocessor. It takes in heavy current capacity power supply, and then based on various inputs will supply power to turn on various outputs, such as the scrub brush motor, solution solenoid, or wheel drive motor. The service manual shows the location of each function board connector, along with a table to identify each circuit contained at each connector pin. The J6 connector may or may not have a small jumper bridging the two pins. If the machine has the EcoFlex detergent mixing system, the jumper should be removed. Otherwise, it should remain in place. If you replace the function board on an EcoFlex model, it is important that you remember to remove the jumper. If you don't, the function board will not know that it should operate the detergent pump.
The control panel is an adhesive piece that looks like this. You can see there's a clear window here. That window is for this display to shine through, like this. And this is called the display electronic board. Now, between the control panel and the main board, or the function electronic board as it's also called.
This is the control panel, or sometimes called dashboard. Each of these is one of the ribbon connectors between it and the display board. And then the display board is wired by these wires here to the main board, or also called the function.
The function board and the display board are connected by just 5 wires. 2 of them are for power, 2 of them are for communication, and 1 of them is the key on signal to wake up the function board when the key is inserted or the power button is pressed.
Here are the 5 wires that run between the function board and the display board. You have the positive and negative power supply that the function board provides to the display board, and then the 2 serial communication wires and the key switch input from the
Let's look at the circuits between the function electronic board and the display board. Down here, the red wire, we have basically full battery voltage, 24 volts. That is power coming from the function electronic board. Over here on the black wire is the negative supply. And we have nice low voltage indicating we have a good negative here. This orange wire is the key on wire, And I have to turn it on. And now we have just about 24 volts. And then let's look at a communication. One of the communication wires, we're seeing about 4.6 volts on that one. And then the other communication wire, a little less, 4.1. Let's change the meter and see if we can see any type of communication going on.
Here you can see the square wave signals going across the meter display here, indicating that there is some type of communication going on.
Depending on what document you look at, this may be called the dashboard control panel, or the dashboard instrument board, or simply the dashboard. The main role of the dashboard is the interface between the operator and the machine. The operator presses the buttons, and the LEDs provide feedback to the operator. The multifunction display also provides feedback to the operator, but that is part of the display board. The dashboard is hardwired to the display board by these two ribbon-style connectors.
The ribbon connectors between the dashboard and the display board are represented right here on the wiring diagram.
The control panel switches can be verified using a voltmeter. On the back side, find the right pin. When you back probe it without the button pressed, you can see you have about 3.1 volts, so just over 3 volts. I'm going to press the correlating button here. This is the burst of power button. See how the voltage drops to 0. I'll release the button, pops back up to 3. Down here, 1, 2, 3, 4, 5 is the vacuum button. You'll see we can do the same thing here. Watch the voltmeter drop, and press the button. Each time I press the button, it drops from 3 volts down to 0 like a typical low-side logic switch.
The service manual identifies each pin of each ribbon connector to help you identify and test any button switch input.
When I insert the gray user key, the display goes to the normal user mode. And first you'll see the hours and the type of battery that's stored in the main controller, and then the normal operation screen. Brings you to the super user screen. Here you can change parameter settings, view the alarm log, look at hour meters, or hit the work button so that you can use the machine.
For those of you who are curious, the bottom of the board here is what reads the key. I can demonstrate that if I hold the key up against here. You can see how it turns on.
When using the gray operator's key, the multifunction display may show one of several different screens. When the machine is first turned on, it momentarily shows the hours of operation and the battery type that is stored in the main controller's memory. After that, the normal operator screen shows information related to scrubbing operation, including solution flow quantity, brush working mode, vacuum mode, battery charge level, detergent flow quantity, detergent percentage, and EcoFlex system override countdown timer. If either the rabbit or turtle buttons are pressed, the speed setting is shown. If the machine sits inactive for a time, a countdown timer is shown before it goes to sleep. If the machine is equipped with an onboard battery charger, the current battery charging phase is displayed during charging. On models with the optional EcoFlex detergent mixing system, if the operator chooses to drain or purge the detergent tank, this screen will be displayed.
parameter settings allow you to set the battery type and modify certain machine behaviors. To tell the controller what type of batteries are in the machine, you have to enter the parameter settings and cycle through until you find battery type setting. Now the current value is 1, which is a gel or AGM. That is what this machine has. But to change it, I can use the plus button. Number 2 is gel discover. Number 3 is gel optima. Number 4, number 5, and I'm going to go back to where I started. Oh, there's wet. There's 1. I want to save it and go to the next thing. Now the battery type is saved in memory. And that's important so that the machine uses the right voltage threshold for the low voltage cutoff feature.
The service manual lists all of the parameter settings that you can change. The table includes the parameter code, description of the parameter, the minimum possible value, the factory setting value, and the maximum possible value. Some parameters, such as the EcoFlex function timer, can be considered as user options, which merely customize certain machine behavior to suit the operator. The installed battery type parameter can be considered a configuration menu, where the controller is relying on you to tell it how the machine is equipped. If you replace the batteries in the machine with a different type, you need to change the battery type parameter setting to match the batteries you installed. This is important. Otherwise, the charger will not use the correct charging profile, and the low voltage cutout threshold values that are used may also be incorrect.
Alarm log provides a history of alarm codes. You can clear the history of alarm codes by using the reset button and holding it down. Hour meters provides recorded operation time for the key on, drive, scrubbing, and vacuum. Work switches to the normal operation mode as though you inserted the gray key. There are also some hidden parameters. Here's how you access them. Using the super user key, enter the parameters. Once in the parameters, navigate until you find the reset screen. Now, while on the reset screen, hold down the EcoFlex and vacuum buttons and press the one-touch scrub button. That brings you into the Hidden Parameters menu.
Hidden parameters which have a note of warning in the service manual should not be changed unless you are specifically directed to do so by a factory representative. For example, look at the VS1 Brush 1 motor protection threshold. The factory setting uses 30 amps as an alarm code threshold. If the controller sees more than 30 amps for a certain period of time, it will shut off the scrub motor and set an alarm code. This is to protect the motor from overheating. If you increase this value, the motor could overheat during operation. The electrical system consists of the foundational items like the batteries, the battery charger, and circuit protection. An optional onboard battery charger is available. It is an SPE model CBH D1XR. It is capable of receiving power sources from 85 to 264 volts AC and 50 to 60 Hertz, so it can be used in many different markets. It has built-in protection for polarity inversion, short circuits, overvoltages, and thermal protection against overheating.
When the battery charger is plugged in, the machine's not allowed to operate. Even if the key is inserted, it won't turn on. And if the operator pushes on the paddle, the machine will not move. This is intentional, and it's part of the battery charger interlock feature. The battery charger and the function board talk to one another. When the battery charger power cable is plugged in, the battery charger calls up the function board and asks, hey, what type of batteries are installed in the machine? He needs to know so that he can use the correct charging profile for the batteries. During charging, the charger regularly tells the function board the current charging phase so that the function board can display the information to the operator. When the battery charger is plugged in, it will display charging progress in the display window to the operator.
The function board sends battery volts out one pin to the battery charger interlock circuit. This circuit is called battery charger enabling power supply on the machine wiring diagram. If the charger is not plugged into a power supply, the power flows through the normally closed battery charger interlock switch and back into the function board on another pin. This circuit is called enabling from battery charger on the machine wiring diagram. If the charger is removed from the machine, these two circuits must be bridged with a jumper for the machine to operate. When the battery charger is plugged into a power supply, an internal relay is energized, and power is removed from one circuit and applied to another pin on the function board. This circuit is called power supply from battery charger on the wiring diagram. When the function board sees power on this pin, he recognizes that he should be in the battery charging mode, and he disables all machine function, including the drive system. The control panel multifunction display will show the current battery charging phase. The battery charger and function board talk to one another on a single wire. This circuit is called battery charger data communication on the machine wiring diagram. This is a scope pattern of the communication line between the battery charger and the function board. It demonstrates the digital communication that is taking place. There is a main 100 amp fuse inside the function board under the black cover. There is also a signal circuits fuse plugged into the function board. The SC500 has a low voltage cutoff feature to protect the batteries from over-discharging. If the battery voltage drops below a certain threshold, the function board will turn off the scrub brush motor. The vacuum motor remains on to remove water left on the floor. If the voltage drops below the next threshold, the vacuum motor will be shut off. If the voltage falls below the next threshold, the drive wheel motor will no longer operate. The voltage thresholds used are different for wet and maintenance-free batteries. The battery type parameter value is used by the function board to select the correct voltage thresholds. The function board monitors the battery charging process and will log conditions where the batteries are being abused. These logged conditions will not show up as an alarm code to the operator, but they will be recorded in the alarm log for the technician to retrieve. If reduced battery life occurs, the log records may provide some evidence of why the batteries failed. If you have successfully retained the information in this lesson, you will be able to identify where the battery charging profile information is stored, identify what the battery type machine setting is used for, list all of the controllers on the SC500, identify the component the paddle potentiometer is connected to, explain how the dashboard, display board, and main board interact with one another, identify the different keys that are available, and identify where to find alarm codes. There is a quiz ahead that will prove whether or not you retained the information provided here.